Welcome to Eduhubscience, your one-stop solution for all your science learning needs. We're here to fuel your curiosity, enhance your knowledge, and empower your academic journey. At Eduhubscience, we believe in the transformative power of education, and our mission is to make learning accessible and enjoyable for everyone. We provide high-quality educational content, meticulously tailored to align with the CBSE curriculum, all designed to foster an engaging and effective learning environment. From complex scientific phenomena to the intricate workings of the natural world, we break down these concepts, making them easy to understand and remember. We're not just about imparting knowledge, we're about sparking that aha moment, that spark of understanding that turns the complex into the comprehensible. So, whether you're grappling with gravitational forces or delving into DNA, we're here to guide you every step of the way. Today, we delve into the fascinating world of Haloalkenes and Haloarenes, so buckle up and get ready for an exciting journey into the heart of science. Haloalkenes and Haloarenes. These might sound like complex terms, but trust us, they are not as intimidating as they seem. Let's break it down, shall we? The term haloalkenes comes from two words, halo, which refers to halogens like fluorine, chlorine, bromine, and iodine, and alkenes, which are hydrocarbons with a carbon-carbon double bond. So, in essence, haloalkenes are hydrocarbons where a hydrogen atom has been replaced by a halogen atom. On the other hand, haloarenes is a combination of halo and arenes. Arenes are aromatic hydrocarbons, the most common of which is benzene. So, haloarenes are compounds where one or more hydrogen atoms in an arene have been replaced by halogen atoms. Now, how are these compounds formed? Well, haloalkenes and haloarenes are typically produced through halogenation, a chemical reaction that involves the addition or substitution of a halogen atom. In the case of haloalkenes, this usually involves halogen addition to alkenes, while for haloarenes, it's typically a substitution reaction with an arene. But why are we talking about these compounds? Well, haloalkenes and haloarenes play a significant role in organic chemistry. They're used as starting materials for many syntheses. Their unique properties, like their reactivity towards nucleophiles, make them versatile tools in the construction of complex organic molecules. In addition, many of these compounds have practical applications in our daily lives. Some haloalkenes and haloarenes are used as solvents, while others are utilized in the manufacture of pharmaceuticals, dyes, and polymers. So, while the names may seem daunting at first, haloalkenes and haloarenes are not only fascinating, but also incredibly relevant to both the field of chemistry and our everyday lives. With the basics in place, we can now explore the properties of these intriguing compounds. Why do we care about haloalkenes and haloarenes? Well, their properties make them incredibly important in the field of chemistry. Diving right in, let's first talk about the physical properties of these compounds. Haloalkenes and haloarenes are typically colorless and have a pleasant smell. They have higher boiling points compared to their parent hydrocarbons due to the presence of halogen atoms, which increase their molecular weight. Also, they are insoluble in water, but soluble in organic solvents, which is a handy characteristic in many chemical reactions. Let's move on to their chemical properties. Haloalkenes and haloarenes are known for their reactivity. Haloalkenes, for instance, have a double bond, which makes them highly reactive. They readily participate in addition reactions, where a molecule is added to their double bond. On the other hand, haloarenes, with their aromatic ring, are comparatively less reactive due to the presence of resonance stabilization. This makes the carbon-halogen bond less polar and less susceptible to nucleophilic attack. Another aspect that makes these compounds interesting is their stability. Haloalkenes are generally less stable than their corresponding alkenes, mainly because of the electron-withdrawing nature of halogens. However, they do show stability under certain conditions, such as in the presence of peroxides. Haloarenes, on the other hand, are quite stable due to the delocalization of electrons in the aromatic ring. Finally, let's talk about their other significant characteristics. Haloalkenes and haloarenes are known for their ability to undergo a variety of reactions. These include elimination, substitution, and addition reactions, which makes them versatile players in the field of organic chemistry. Understanding these properties not only enhances our knowledge, but also opens up a world of applications. So let's keep exploring, and in our next section, we'll delve into the practical uses and applications of these fascinating compounds. Stay tuned! Haloalkenes and haloarenes are not just theoretical concepts. They have practical applications that influence our daily lives. Let's dive right in. Haloalkenes and haloarenes are integral in the pharmaceutical industry. Ever heard of the term antibiotics? Yes, you got it. Many antibiotics, including chloramphenicol and fluoroquinolones, have a haloalkene or haloarene structure. These compounds help us fight off infections and keep us healthy. Now, let's talk about agriculture. Haloalkenes and haloarenes play a significant role in the production of pesticides and insecticides. DDT, an infamous insecticide, is a haloarene. Despite its controversial environmental impact, there's no denying its effectiveness in controlling pests and boosting crop yield. But that's not all. The versatility of these compounds extends to the plastic industry as well. Polyvinyl chloride, or PVC as it's commonly called, is a type of plastic made from a haloalkene. From the pipes in your house to the insulation of electrical wires, PVC is everywhere. Moving on to a less known application, the production of refrigerants. Chlorofluorocarbons, or CFCs, made from haloalkenes were once widely used in air conditioners and refrigerators. Even though their use has been phased out due to environmental concerns, they were instrumental in the development of modern cooling systems. Lastly, let's not forget about their role in synthetic fabrics. Haloarenes are used in the production of flame-resistant materials. So, the next time you see a firefighter rushing into a burning building, remember that their protective gear likely contains a haloarene compound. As we can see, the study of haloalkenes and haloarenes connects us to real-world applications, making it an essential part of the CBSE Class 12 curriculum. These compounds are not just scribbles on a blackboard. They are powerful tools in our battle against disease, hunger, and danger. They are silent heroes, shaping our world and making it a better place. So embrace the complexity and dive deeper into the world of haloalkenes and haloarenes. You never know, you might just be the one to discover their next big application. Before we wrap up, let's revisit the key takeaways from today's session. We started our journey into the world of haloalkenes and haloarenes with a clear definition. Haloalkenes and haloarenes are a class of organic compounds that contain halogen atoms, replacing one or more hydrogen atoms in hydrocarbons. The haloalkenes have their halogens attached to the carbon of an alkene, while in haloarenes, the halogens are connected to the carbon of an aromatic ring. We then proceeded to delve into the intriguing properties of these compounds. We learned that haloalkenes and haloarenes are polar in nature due to the presence of halogens, which are more electronegative than carbon. This polarity results in these compounds having higher melting and boiling points than their parent hydrocarbons. We also discovered that these compounds exhibit varied reactivity due to the presence of the halogen group, which can be a leaving group in many reactions. Our exploration didn't stop there. We dived into the myriad applications of haloalkenes and haloarenes in our daily lives. We found out that these compounds are not just limited to the pages of our textbooks, but extend to the real world, playing significant roles in the pharmaceutical industry, in the synthesis of polymers, and even in the making of insecticides and pesticides. In essence, haloalkenes and haloarenes are fascinating compounds that seamlessly blend the world of chemistry with our everyday lives. They are not just theoretical entities, but practical substances that shape our world in ways we often take for granted. So that's a wrap on our brief exploration of haloalkenes and haloarenes. But remember, this is just the tip of the iceberg. There's a whole universe of knowledge waiting for you to discover. With that, we conclude our quick tour of haloalkenes and haloarenes. Remember, the world of science is vast and intriguing, so keep exploring, keep learning with Eduhubscience.